All right, so for those of you that are just joining us, if you have a laptop, I recommend taking it out, trying to get some environment up and going so you can follow along. It would make things a little bit more interactive and also help to solidify some of the stuff. I'm a tactile learner, so I like to do stuff in order to learn it versus just being told it or reading it. It doesn't really sink in for me. So there's a couple labs that we're going to go through. First, there's a little bit of information to cover, as always. And I've got a flash drive being passed around that has 2 samples on it. That's for the kind of end of our course or our workshop while we're actually trying to reverse engineer some samples. And in the beginning, we're going to actually go through and develop a couple of things. So if you have a Windows VM, that's kind of what we're going to be basing a lot of the stuff we're doing today with. And Visual Studio has an Express version with C++. So if you have a Windows VM or a Windows laptop, download Visual Studio. It'll help you kind of be able to bridge the gap between developing C++ programs and actually reversing them. So for those that have not got the samples yet, as I said, we'll be doing that a little bit later, so there's still time to get them. Right now, the flash drive is up here, so once you're finished, please start passing that towards the back for any of those that have not got those samples yet. All right, well, I guess we're going to get started now. Welcome, everyone. Good morning for you early risers. I say early risers because, you know, it is before noon, so it can be kind of difficult to get out of bed, especially at a conference. My name's Angel. I'll be working with you guys today. We're going to talk about reverse engineering C++. There's a lot of intricacies that go along with it, especially when you're actually programming C++. Full disclosure, I'm not a C++ programmer. I've developed in C++ before to patch things from here to there or to update code. Mostly my experience is being C with a couple C++ isms. How many people can relate to that? How many people know C? And when they see the extension .cpp, they're like, oh yeah, I got C, I got this, no problem. Easy to do. That's what a lot of people generally do. But when you actually start leveraging C++, it can be a very powerful language, and it's also a lot better and a lot cleaner and more organized to use C++ when you're doing bigger programming projects, because it provides a better way of passing around information or abstracting implementation details than C provides a lot of times. All right, if you guys have any questions at any time, please let me know. Flag me down, try to like wave or something. We're going to start off first by talking about differences between C and C++. How many people know C? Can I get a raise of hands? Sweet, okay. Anyone here know Python? How about Java? C#? Sweet, so you guys know how to program, great, awesome. That helps quite a bit. So going from C to C++, you know, you're going to take constructs of your basic syntax of loops, different logics. All those are still going to be incorporated, but now we're going to start bringing on a new paradigm of, now we're going to have objects. We're going to actually have classes to help organize and store data. Think about it in C, we have a lot of structures. We can define structures in order to pass along references to more than just calling a function with 12 arguments because we have the need or possible need of one of those 12. We can pass along a structure that encapsulates all that information. With C++, we're going to be able to also pass along classes that we'll be able to leverage in different places via knowing the interface that it exposes to those using the class and also understand kind of its inner workings. But in order to do that, we have to understand polymorphism. So for those that have done C#, those have done Java, you're already pretty familiar with it. This will be just a basic quick overview. With C++, we also have relationships between classes that become very important when we start reverse engineering it. And this really becomes essential when we start talking about binding types. And I will get into that more later. Finally, we'll wrap up with just trying to develop some broad methodology in order to help you understand and look at a C++ binary. When I first started reverse engineering, C to assembly, okay, cool, I'm learning assembly, this is a little difficult, I'm trying to understand all this stuff, try to see the forest instead of looking at the trees, all that stuff. Look at C++, nope, forget that, moving on. I have no idea where all these pointers are going to, all these structures. It can be a little daunting at first, but if you understand the kind of the core part of it, it becomes basically just like reversing C or any other compiled language. All right, so let's start branching that knowledge between C to C++. This is not comprehensive in the least bit. I'm just going over the least amount in order to help us know what we need to look at and understand what becomes in, or what happens when we're developing C++ and what it becomes when we're reversing it. So a lot of things we actually don't end up paying attention to. So I'm just going to focus on the things that make sense and that help us to understand when we develop it and when we look at it. We have a couple of new keywords. There are many new keywords, but the ones we're going to focus on are namespaces. We're going to focus on visibility issues, and those are like private, public, protected, and also the this keyword. We have, when programming, we have the scope operator. We also have constructors and destructor, and getter and setter methods. So for all those that have done Java, pretty simple, pretty basic, no problem whatsoever. When we think about reversing, though, the namespace. Namespace is just basically syntactical sugar for the developers. It allows you to easily access functions instead of fully quantifying, the module that they're a part of and then the function name. With namespaces, we're able to include a whole module itself and then be able to access those functions via calling them directly instead of fully quantifying them. Visibility issues. When we develop, by default, C++, any class, well, I'll show this a little bit later, but any class declaration, all members are private unless otherwise declared. So private, can someone tell me what private means? Yes.
Accessible to the scope of the class?
Exactly.
By external objects?
Exactly. So in case anyone didn't hear that, it's anything that's marked private is only accessible within inside the class. It's not accessible outside of the class. Keep that in mind. All right. Public, what's public?
The opposite?
The opposite, okay. Good. We got one person that's awake. Everyone else is still here, hopefully. And then we also have protected. What's protected? See the guy over there?
It gives access to subclasses, but not externally. So it's not public, it's accessible internally, and it's accessible to subclasses.
Exactly. So for those that couldn't hear that, protected basically gives us a medium between the two. But it's still not accessible outside of the class. It's accessible to the class and any of those that inherit from the class. All right, so polymorphism. So this we start talking about involves the overloading of methods. Now, a really good example of this is just constructors itself. When you have a class, when you define a class, by default, it's going to have one constructor, whether or not you define it. If you define it, you can supply any number of arguments. But with C++, you can actually define more than one constructor. So you can have a constructor with no arguments, a constructor with 10 arguments, very bad programming practice probably, and any number that you want whatsoever. The way that this happens in C++ is due to name mangling. We're able to take one function that's already defined and be able to redefine it as another function that has maybe different arguments or different number of arguments. In addition, C++ gives us really cool, another syntactical sugar thing where you can overload operators. So if you have one class, let's say number, and you add another number to it, instead of having two integers, actual integer values adding, you can take number class plus another number class and combine them together. It's just kind of a very interesting, niceties that C++ affords those programming with it. All right, so here's an example. Overloading functions is not just limited to the constructor. It's kind of the easiest example to talk about, but we can also overload with functions defined in a class. So for those of you that have done C++, this is a very basic, trivial example. For those that haven't, there's a couple things to note. First, we have a class declaration. Class declaration is somewhat similar to a struct definition, except for in a structure, in C, you cannot have functions that are actually corresponding inside them. You might be able to store function pointers and then call them later to kind of get around that. But with C++, we can actually define our own functions in it. Now, this chunk of code, what's the visibility of these functions here? Someone says public.
Well, it defaults to private, doesn't it? 'Cause it's not declared.
Defaults to private, correct.
Yeah, but shouldn't the constructor be public rather?
It should be. It definitely should be. But if you were to take this chunk of code, paste it into Visual Studio, and try to create a new instance of this class, it will say that this constructor does not exist. So keep that in mind when you're programming. It's easy to think, oh, constructors should be public. They should be accessible to anyone trying to access it. However, it's all dependent on what exactly you define. So all this is private, though it needs to be a little short code segment in order to put into the slide. We're just going to assume that's public, okay? So these are public. Skyscraper, this is a subclass of building. Building is its parent. This is the notation for defining that. And skyscraper has two functions. They actually are named the same thing. And this is another place where we're dealing with overloading. So at compile time, what happens is the compiler will look at and understand the parent class has get number of floors. It will compile that down to a unique identifier for that class and the function name in addition to its arguments. When it looks at skyscraper, it will do the same. So there will be two get number of floors, and each of them will be their own. When we look later at developing some C++, we'll be able to look at the disassembly and we'll see the name mangling and how it occurs. Any questions so far? All right, here's another example. Just because usually when you start talking about C++, you talk about overloading operators, people are like, wow, that's really interesting. I want to see an example of that. This is just a quick slide to show an example of that. Here we have a person class. We're overloading the ++ operator. So we're incrementing a person. This is a good way for us to say, hey, we actually want to increase the person's age instead of creating a function that takes in, or a full declaration of person dot increment age by 1. That's a long name to have in your code, and you probably want to shorten your code. Now that we've seen a little bit of code chunks, let's start talking about more like class relationships. In C++, there are 3 different types we're going to talk about today. The first one is containment. So you're going to have different classes. Class A will contain class B. That's what we're referring to. So here on our side, we have square, which takes in a length and a width. It might have other functions that make it its area. So if it has a function area, that's going to be really helpful for the cube class. It doesn't have to go through and understand how exactly square is implemented. It just knows that it can call its getArea method, get its area, and then calculate the remaining area by multiplying it by its height. Another class relationship we have is association. This we see all the time. There's certain classes that have certain methods that are available to us as programmers. You can kind of think of it as different APIs. I come from a Windows background, so I do a lot of Windows programming, Win32 functions. We have structures. We know exactly what functions take what arguments. Think of association as the same way. We have class A that knows about class B's functions that are available to it. Now, if class B was ever to change, or maybe it's a class that's linked in dynamically via loading another DLL and including it, then that could cause some issues if ever those prototypes change. Our last type is inheritance. Now, this becomes really important because it helps for us to define abstract interfaces or generalizations of classes that we're going to use. It also easily provides ways to have different class types that we then can either cycle through in a program. So let's say maybe we have a parser class. There are many different parsers. Maybe we're taking in a CSV. Maybe we're taking in an Excel document. Maybe we're reading in HTML or XML. All those are different parsers in themselves. Having a parent class as a parser helps us to generalize stuff and also to expose certain API that can be leveraged no matter what kind of parser it actually is. All right, so now I've done a little bit of talking about these different types. I want to actually go through Windows 8. Forget that it automatically puts it in standby if it's not used after a while. All right, so now we should definitely make a class. Try to fill in any gaps that might be left from me just talking about the different class aspects. If you guys want to, feel free to follow along, pull up Visual Studio. I can create a new example if we want, or I can go over an example that I have already programmed. What do you guys would like to do?
How complex is the thing programmed?
It's pretty simple. It's got a lot of the main components. With us doing it live programming, it'll allow us to kind of just fill things in as we go. So we need a class. Someone give me a class, an idea for a class.
Animal.
Okay. You know what? I feel like maybe you and I worked on this presentation because, that's what I was thinking. All right, animal. What kind of things would an animal have? First, I'm going to define public and private. Now, while I type, I'm going to do a couple things, and then I'll zoom in and zoom out to help you guys read it for those that are not developing it yourself. All right, so we need a constructor. A constructor is defined by the class name. Since we named it animal, do we want to have any arguments for this? People say no. They're just an animal. What was that?
Number of legs.
Number of legs. All right. We'll make this an unsigned int, because we don't want to have an animal with negative legs. See, this is way better than going over my example. Who knows what can happen? All right, anything else? No? All right. So if we're taking legs, we definitely want to store that somewhere. Having it in the constructor is not going to get us anywhere. So we'll create a private field called legs. Note that we have note that I named it legs in both instances. Much like with Java or C#, this can be done, but we need to use this operator. So we'll assign that there. Now, right now this doesn't really do much, but if we have the number of legs, I'm sure at some point we want to know the number of legs. So we need to make a getter method. This is just like any other thing. Turn unsigned. Int get legs. Since now I no longer have a collision between argument names or local variable names or global names, I could just say legs if I want to. Or if I want to make it easier for those looking at my code later, I can do this. Sometimes I want job security, other times not. For today, we'll put the this in order to include it. All right, anything else? All right, well, just to make things interesting, we'll add another, whoops. And we'll make this, we'll give the animal a name. One of the nice things about C++ is the inclusion of a string object. This kind of makes using char pointers or Unicode pointers a thing of the past, which is really nice. And also to make things interesting, I will, oops. Including namespace will allow me to now specify let's say in our constructor. In standard library, there is a cout. So cout allows you to print out to the command line. So think of it as your printf. Just a little bit nicer in certain respects, especially depending on the arguments that you choose. So I can say, oops, I can pop a lot like popcorn. All right. All right, so now whenever the constructor is called, we're going to print out this animal has however many number of legs. Oops. Actually, I do want to. So unlike printf, usually, do you need to define a new line character?
Yeah.
Yep.
I'll-
Yep, you do. So much like cout, anything you pipe out to cout, it's going to do it without any new lines. So for our own sanity when reading this, we probably should include new lines. All right, let's actually make it a destructor with this. A destructor, what does that do?
Freeze it. Memory automatically.
Yep, so C++ brings about this new concept of actually managing some of the memory that you create, which is both a good and a bad thing. So in C, everything that you allocate, you need to make sure to free. There's no free lunch where garbage collection is going to happen and you don't have to worry about it. You just keep allocating all day long. With C++, there are a couple cases where objects that go out of scope and no longer have references to them via pointers are going to be deleted via calls to their destructor. So if we were actually using more primitive types, let's say a char pointer to keep the name of the animal, then we would make sure that we actually deallocate that buffer when our animal is destroyed. Keep in mind that for destructor, there is only one per class. Trying to define multiple ones will lead to errors and the inability to compile your code. Nope, that's. Oops. All right, so in our destructor, if we provide a name for our animal, and we've grown attached to it, and we actually care if it dies. I just put a quick statement saying so. Test. To create an animal instance, much like in C, you have the opportunity to put things either on the stack or in the heap. To create a class object on the stack, keep in mind, once that function returns, that is no longer going to be on the stack, in which case the destructor will be called on that object. If we wanted to, we can create on the heap and then pass it around. That also has different benefits and unfortunate side effects. So sometimes if you do not free this memory, you might have a memory leak. But simply doing this let me go back real quick. Visual Studio showed me a pretty good point. Gotta love technology nowadays. If you have a default constructor, that's a constructor without any arguments, a declaration such as this is all you need in order to create a new object on the stack. Nothing else is needed. If, however, we want to use one of the actual constructors we created, we can define it such as this. If there are no arguments, providing empty parentheses I think will also work. However, we want to make use of one of these. So let's create an animal with, let's call it a spider. How many legs do spiders have? 8 or so. Okay, good. Making sure you guys are still awake. Now, if we create another animal, cow, and we pass it, what are we going to name our cow?
Steve.
Was that a moose? Steve?
Steve.
Okay. Now in our test function, we have made use of all the different types of constructors we made. Since all of these are created on the stack, we provide simply cow dot as if we created a structure on the stack. Now we can get the number of legs, we can get its name, we can also invoke the destructor ourselves. So yet again, I'm just printing out some stuff. What am I going to print out? Steve is eating some grass. Don't forget my new line. See out. Spider dot get legs. Since we are not too sure how many legs our spiders have, it's going to print out, has 8 or so legs. Just to help further illustrate this, let's all right. So hopefully, this is the great part about demos. We have no idea what can happen. I probably mistyped something. Let's find out. How many of you are not familiar with Visual Studio? Okay. All right, cool. In that case, I will give a brief little overview before we do our lab of how to just generally use it to make things a little bit easier for you guys. Over here in this area, if we click within there, we can actually set breakpoints at different lines. So that's what I'm going to do. I'm going to create a breakpoint here in our main function. And what I just did, I don't know what version of Visual Studio you guys are using. This is 2013. But notice that test is kind of bold, whereas pets is not. Test is set as the default project, so when I start a new debugging session, it's going to actually start running the one that's set as the default. Awesome, it compiled the first time. I'm doing good this morning. This is great. All right, another thing I want to show you guys, this is where we're going to help start bridging our gap between developing C++ and actually reversing it. Visual Studio allows you to look at the disassembly. This is going to help you to see, okay, I have got a call to a function. This function is either an actual function or it's a method of a class. When we're looking at it, we see that a call to test, which is just a regular function, is seen as a call to the function. Plain and simple, easy to do. Oops, don't want to look at that one. That's one I created before. All right. On the side, we've got a couple of different buttons. So I'm using VMware Fusion, and unfortunately, VMware Fusion doesn't like when you do F11. It's reserved for something else, so it doesn't go across correctly. If you guys are using Fusion, you might have the same problem. But F11 is the step into. F10 is the step over. And I believe it's Shift F11 will step out of. So I can hit those buttons there and still get the same effect. So I'm going to step into test. And I'm just going to press F10 to continue stepping. Move this over to the side so we can see this. Start creating an animal. Remember, we have absolutely nothing going on in the default constructor. That was just to show you guys that it's needed in order to provide it with no arguments whatsoever. With Spider, we have, it should be printing out the count, right? So let's step over. Oh, fail. Okay, clearly I'm not doing good. We've got an invalid null pointer. And this is probably due to me switching up between char stars and strings. So this right here is probably an unacceptable thing to do. Who recalls the, the API for getting the length of a string in C++? You C++ programmers out there. So this should work. Name is a string class. Thanks to Visual Studio, you can see its methods underneath it. We've got append, assign, at, back, beginning, all this stuff. Length should work. Nope. Does not. See, this is what I get for listening to you guys. I create a name. Now I don't even remember how to do that. All right, in that case, I'm going to just simplify this. Wow. Okay. All right, now we've fixed that. We see that it prints out animal has 8. I think I forgot to include legs on that sentence, but we get the idea. Now we go down to Steve, our cow. Got that printed out. We see we can access members. So this is a property, cow.name. It's marked as public, and that's the reason why we're able to access it. If we try to do cow.legs, that would not work. That would actually give us a compilation error. Step some more. We see that our spider has 8 or so legs, and this exception is occurring because we deleted, we changed it from a string to a char pointer. Now that buffer is trying to be deallocated, which is causing error. But notice here, destructor, we didn't actually invoke the destructor ourselves. It happened at the end of the class because those objects were created on the stack versus on the heap. And due to that buffer being deallocated, that's where our error occurred. So this should say, oh no, Steve has died. The way to get around that error, which I will save for you guys doing a lab, what you would do is you need to copy over that string over to a new buffer that's allocated for that class object. So that way that class has access to that string, and then free it in the destructor. All right, so here's another class that I created. This class is just kind of also showing some of the additional points that we want to make sure we know for when we're developing our own. So the IO stream is just so I can use the cout, pipe things to and from it. Again, using the standard namespace. Here I just defined a kill for delete. That's another way to invoke the destructor, as we'll see a little bit later. Here I have a class pet. We got a protected name. We also have 2 different methods that we can call with it, speak and then also to get its name. We're going to use pet as a parent class with dog as the child class. With C++, if we wanted to, we could actually do comma and then provide multiple parents. So if we had some crazy class that needed to implement functions defined by another abstract class, we could do that easily. By default, this is private, so even though we don't have it actually declared as private, it will be. One way to just quickly show and test that out is if I was to come down here to spike, do a dot. Notice we don't have coolness. We have another class, cow, that inherits from pet. We've got a constructor. Constructor element, a destructor. more methods that are implemented. So these will override any that pet may have. And then we just have a couple of functions to further illustrate a couple of different things. So here I've got a dog named Spike, cow named Betsy. We've got a function where we're creating Old Yeller, and Fido. This is something we haven't talked about yet. But down here we have a concept of creating classes as pointers. This is where we use the new keyword. When using or creating a class in this way, you're basically creating the class object on the heap. Okay? Or sorry, in the heap versus on the stack. So Betsy is on the stack. However, Fido is stored in the heap. Okay? Any questions? No? All right, we'll go more into that example a little bit later. So we're getting ready to go into a lab. Again, keep in mind, constructor. By default, whether you define one or not, you are going to have a constructor with no arguments. If you define a constructor with arguments, then the default constructor without arguments is no longer included. That's why when I tried creating an animal, it said that it doesn't exist because there was no constructor with no arguments. Destructor. Destructor will be there no matter what. It always takes no arguments. Try to create one with arguments and you'll get compilation errors. We've got some getter and setter methods. Remember, there are issues of scoping. So if you create a class but don't provide the keyword public, everything's going to be private. Keep that in mind. In my quick example there, it was just something to show you guys how to go about creating instances of this. In actual development code, what usually happens is you have class declarations with prototypes in them. So instead of actual definitions or implementations of the name function, we would simply have char pointer name, kind of as you would in a C header file where you're providing it with just the bare minimum of the function prototypes that can be used. And the implementation details are actually somewhere else. They're either in another file or hidden away under many layers of long bits of code. So when you create a class with just the prototypes, you actually need to go through and implement them. If you were to do that, you would use this kind of syntax where you define the class name, make sure that this prototype matches the prototype inside the function, and then the : will provide you the scoping operator. This will let the compiler know that age of 1 year is a method of that class. Keep in mind, this will not work because we haven't actually defined age 1 year inside here. So if you were to create a class prototype, make sure to define them in the class and then actually do the implementation details in that way. Again, an object created on the stack is simply the class name, the variable name going to be associated with it, and whatever constructor you're going to create it with. All right, so with that in mind, I want you guys to open up Visual Studio and actually start developing a class. So we've already done animal. Let's, man, I was going to use like zoo, and we could have like animals with that, but we need something different. Any ideas? I'm sorry, wait, you said prison?
Yeah, I mean, you can have guards and prisoners and cell numbers.
True, okay. That's not a bad idea. What was your idea?
I was asking, do you want something to subclass animal or do you want a new procedure class?
I think we should just go with something different. I mean, if we've already done, I think prison makes a pretty good idea. That way you guys can, if you want to, create a building class. Maybe there's like cells inside of a building or implement the people that are inside of it. So we're going to go into just a little bit of lab time where I want you guys to use the topic of prison. This sounds really good for my class. And I want you to create at least 2 constructors Three different properties, a couple of methods, at least two. Make sure to make getter and setter methods for those properties. So that way you have access to them outside. And then create a small little program that leverages those classes. Feel free to use inheritance if you want to, or just create basic classes that will basically just utilize just whatever's in that class. And a destructor is optional if you guys want to do that. I'll be walking around to help out if you guys have any questions. And for those of you that do not have laptops, if you want to still run through this, maybe we can work on the whole buddy system. You can pair it with someone that does have a laptop, or we can kind of huddle up here and I can kind of do some programming with you guys. Okay? Also, has everyone got the samples from the flash drive? Anyone else need that? You need it? Okay. One second. Okay.
I have a question.
Mhm.
Do you know how this result? This doesn't make any sense.
Maybe I have the wire too tight or something?
That's what it sounds. It seems fine.
I'm going to give you guys about 10 minutes, and then I'll check in to see how things are going. And if everyone's done at that point, we'll move on. If not, then I'll give another 5 minutes to wrap up. Does that sound good?
Thank you very much.
No problem. And please feel free to flag me over if you have any questions or having any compilation errors. It's definitely not worth it to bang your head against the wall for 10 minutes trying to figure out one compilation error. All right, guys, how did that go? Visual Studio, was it nice enough to you, or did it keep giving you compilation errors over and over again? Yeah. All right. Any examples or things people would like to share? Something that was noteworthy? You thought your prison or prison-themed C++ program was noteworthy? I see a couple smiles, so clearly there's some good stuff out there.
Well, when you go to reversing, I'd like to see how it comes out. I've done some inheritance
Okay.
with virtual functions and see how that looks.
Great. Okay. So, I'm sorry. What's your name? Bapa. He was talking about that he created some classes with some inheritance, and we're definitely going to get into reverse engineering these samples soon. Just to show another example, I will show the one that I did. Oops. All right, so again, the prompt we asked for 2 constructors, a couple properties, 2 methods, getter and setter methods also. Keep in mind that was just a start, so it did not need to be that minimal, but it could have been, at least. Here's what we worked on. We created a prison class. There we go. Our prison has a couple of properties, the number of cells, number of prisoners, and we have a number of wardens. And we also have this Boolean value for doubling up, which we'll get to a little bit later. We have 2 constructors. The first one is the number of wardens and the cells. So whenever a prison is first created, we definitely don't want to have prisoners there already. But in the case, maybe we're defining a prison that already exists and we're just kind of adding it to this program. Here we give a new constructor that accommodates having a number of prisoners, having our whole bunk up argument here. So by default, when a prison is created, we're not going to start doubling up. That's going to be reserved for if we have capacity issues. Next, we have our number of cells, both getter method here and a setter method. And we have the same for each of our properties, except for the double up. So in our prison, once we double up, we never go back. That's just the way it is. Times are hard. But we also have another method, guest limit. So this helps us to account for how many guests, prisoners, we can have at a time. Later on, we developed a small little function that will basically add n number of prisoners to our prison. And in our main function, what we have going on here is we create a prison with 10 wardens and 16 cells. We print out in the beginning, this is how many wardens, cells, prisoners we have. And then we try to add our guests. We know that 30 is going to be a lot more than 16 cells can handle, especially when we're not doubled up. So we've accommodated that for afterwards, bunking up in our prison, and then adding the remainder guests. I don't know if you guys noticed, but my prison is on a stack. With that in mind, once we leave the main function, my prison will no longer be available. It will be deleted. Its destructor will be called. We can, however, pass it along to any function that main calls via passing around as a pointer. But keep in mind when you do this, this kind of becomes places that can be security issues, much like passing around a buffer from one place to another, especially if you're passing it around as an address on the stack, because if you aren't doing the correct typing or the correct bounds checking on different operations, you could very well overwrite, and us passing a pointer onto another function could allow for some other function or some other buffer overflow somewhere else to write into places where we do not want it to happen. And this becomes more of an issue when we start talking about vtables, which we will soon. Any questions? So that was pretty simple. Real quick, I'm just going to start this up. And we're going to start bridging that gap between what we created in its actual source code and what we're going to see in assembly. Actually, let me restart this. Start from the beginning, and I'll switch over to the assembly view. Visual Studio is really great about this.
Switch to the assembly view, by the way.
Okay, what you do is whenever you're in a debugging session, you have access to a lot more views. So you'll go to, in the newer Visual Studio, Debug, Windows, and this gives you a lot of options. This can be very, very helpful. So, I mean, we've got our threads, we've got our modules, which are going to be really useful for bigger programs, not really for what we're doing here. But the main thing here is the disassembly view. We also have memory, which will be very important too for tracking down why things are where they are or trying to look at vtables. The immediate window is very helpful for those that are unfamiliar with Visual Studio. Immediate window allows you to do small little C or C++ syntax and have it be evaluated right there and then versus having to stop the program, create a couple lines, create some print statements or some debug statements in order to get information about variables or what's happening at that location. All right, so once you select that, you'll have the disassemble window or tab show up on the side. And wherever you are, once you select over, it will bring you to that point. Visual Studio's disassembly window is pretty nice because it will show you this is the instruction I am executing right now, and the corresponding disassembly for it is this block of code. So we see that our first argument is 10, our second one is 16. Keep in mind, when you're looking at the disassembly, that's going to be in hex. So that's what that H corresponds to. As a little reviewer, when you're calling functions, usually most calling conventions, not all, most though, incorporate passing arguments on the stack from right to left. So the last argument is going to be passed first, and we see that via this push statement. And then the first argument is being pushed. So if we had a third argument, that would actually have a push statement right in the middle here. Now, this is an essential part to C++, the this keyword. And this keyword is basically just a symbolic reference to the object itself, the class. Not the declaration of the class, but the actual instantiation of a class. With Microsoft Visual C compiler, this is generally passed around as the ECX register. So right before a call to our constructor, we see that ECX is being set a value. Okay? What other calling conventions utilize ECX? So standard call uses the stack to pass arguments. Fast call, yep. Fast call will use ECX for the first argument, EDX for the second argument, and then the stack for any sequential arguments. Now this is all on x86 hardware. On 64-bit, it's a bit different because you have it already normalized. There's slack space, tons more registers, all this stuff. But we're dealing with x86 right now, so fast call utilizes it. How can you tell the difference between a calling convention that's supplying all of its arguments through the stack versus those that are supplying it through registers?
Presumably before the call instruction, there will be either be a lot of pushes or like stack operations, whereas with the registers, will be move this to the register and then call.
Yep, exactly. So a lot of times you'll see if things are being put onto the stack, you might see pushes beforehand. However, keep in mind that this is flexible. I mean, there are malware authors out there that handcraft their own shellcode, their own small programs in order to make things a little more difficult. They also leverage and employ obfuscators or code that expands or condenses their code more than what's usually occurring with the standard compilers. So with that, it really comes to the point of what you see in the actual called function. The called function will give you all the indicators you need. Granted, between the this calling convention where ECX is used for the this pointer and then the stack is used for all sequential arguments, it can be a little difficult to understand whether it's a this call or a fast call. So I will step into that. Looks like a lot of gobbledygook, doesn't it? This is just Visual Studio. This is a debug build. So debug build is going to have a lot more stuff that's going to help you to further join between what's happening. However, in actual application or production level code, you're going to see just a straight call to the actual constructor. So here we just have an additional step. We're going into prison, just doing a call to it and then a jump. So once more, I will step into. Now we are inside this constructor. The easiest way that I say to figure out if it's a this call would be to look for the ECX being defined or set a value prior to a call. But keep in mind, optimizations could occur where ECX is being set really early on in the function before the call is even made. However, the ECX value may not have changed, so it really doesn't matter. Great thing to look for is in our function itself, we have ECX. It's being pushed. So at first glance, if I knew nothing about this program whatsoever, I wouldn't be too sure. They could just be creating stack space. They could just be saving the value of ECX to restore it when the function returns. Here we see ECX is being used a little bit more, and then pop. All right, so the value of ECX that was stored is now being returned. And we are seeing that it's being used before it's actually set. So this is a big indicator that it's either a this call or a fast call. Now, how do we decide whether or not it's this or a fast call at this point? Any ideas?
It's a lot of push. There's a yes or not many move operations.
Okay. So we're talking about there's not very many move operations. When you only have, let's say you have a class instance that has a method in it with no arguments. In that case, it's going to look a lot like this call. Or sorry, it's going to look a lot like a fast call. And the only way to really puzzle it out is to look at the function and truly understand how exactly it's being used. But keep in mind that with objects as classes being passed around, they're going to need to access probably either other methods inside of the class, or they're going to access some members with inside them. So these members' properties are going to be at an offset with inside the this pointer. So a great way of looking at that is right here. We have Visual Studio is helping us out a lot by giving us variable names. But we see that ECX is being restored. This is the this pointer. EAX is being assigned dereference of the this pointer. So the first address inside that location. So think about it as we've got a structure. ECX, oh boy, this is just going to get bad. ECX points to this structure. And we are going to start storing stuff in it. So by the way that this is created, we see that the cells are being stored the first place in it. So this is our cells. I'm not going to do that. cells. There we go. And that's in this spot. That is far better. And notice at offset 8, we are storing the wardens. So cells is not, I don't know if you recall, let me actually exit out of that. In our source code, we have number of cells, number of prisons, number of wardens as the actual members inside of the class. And our constructor, wardens and cells, is actually the arguments provided to it. So this is an argument, which makes sense. It's on the stack, so they're dereferencing it in order to get the value that was pushed on the stack for the cells. They're doing the same here for the wardens. So again, I will draw this out. For our class object, what it looks like in memory, this here is our cells. It's at offset 0. At offset 4, what do we have? Well, currently I don't know. I just see cells, I see wardens, and that's at offset 8. So right now, offset 4 is unknown. Offset 8. This is why I'm in computer science, not an artist. Here we have wardens. Then we have at offset 4. Okay, so now we have a little more context clues. Visual Studio is helping us out a ton because, well, I haven't really been paying attention to it, but we have all the source code, what's happening with each definition here. So we know this is the wardens. This actually corresponds to the prisoners. But if we were looking at this sample, it came from nowhere, we don't have any symbols at all, we would have to look at which offsets are being accessed. And this helps you to better understand, okay, this probably is a class, or at least it's a structure being passed along. So then at this point, we have our prisoners or guests. And we can continue doing that. We can continue figuring out how exactly that works. So a couple of really important things. We have constructors, but they're very basic constructors. And note that with the constructors, we had calls directly to those constructors. There was it was a call to a jump, but that was just because it's a debug build versus a release build of this. Now, if I step a little bit, so I'm going to come out of this point. I'm back in my main function. I'm going to switch back to the disassembly. All right, this first instruction is basically a big print statement, but it leverages accessing a lot of the getter methods. Please note that we have a call and the address for where that function is. Why do we think that is? Any ideas? No? All right, cool. Then I've got something to teach you guys. This is good. With that, switch back to the PowerPoint, except for not. Well, that is an interesting effect. Okay. This is where we start getting into the real core of reverse engineering C++ binaries. We talked about the this pointer and how that's usually associated with ECX. However, that's not the extent of it. It gets a lot more complicated. And that happens at compilation time. In our example, very simple example where we're using functions and just accessing them directly, we're using compile time bindings, which basically is early. So at the point that our code is compiled, the compiler can calculate where exactly those member functions are. Those methods of the class instance itself. There's no need to do any table lookup or anything like that because all those addresses are set, much like if I called any other function. Runtime or late binding utilizes the keyword virtual. Now what that means is no longer is the compiler able to figure out, okay, where is this function that I'm trying to invoke in this class? It's going to have to actually dictate that based on some other information. So what other information could it use? And what exactly is the benefit of using the virtual keyword? This comes into play a lot when we start dealing with inheritance. So you'll have a parent class that will have many functions, or maybe just a couple, overloaded by a child class. That child class may figure, okay, I need to accomplish different tasks. And we've done that already. We've seen a parent class and a child class, and that was just basic overloading. With the virtual keyword, no matter what that class gets changed to, think about C, you can cast anything to any other data type and it will just run with it, or at least it will try to until it crashes. C++ also allows the same thing. So we can take a cow and cast it as a dog and expect it to react like a dog. You know, things like that can occur. And it can be very useful in different situations, completely preposterous in others, but we will show an example of that. All right, give me a second. I'm gonna try the old Mac fix, unplug it and plug it in again. And it worked. Awesome. All right, so this brings me around back to my other example, where we talked about, here we have a pet class, we have a dog and a cow. Note the virtual function, or sorry, the virtual keyword. Yes? Was it? Okay. What is going on? So my screen is now working, but this one is not.
You could try mirroring it instead.
That's what I just did. It's just getting worse.
It's madness.
Try that one.
That's strange. Oh, is it your zoom in and out? You zoom away? Yeah, it might be that.
Okay. There you go. Hope you guys enjoyed that little break. All right, I was talking about the virtual keyword. My main function, I have a couple of different instances of these different pets. Anyone have any idea what's going to happen when Betsy tries to speak? So, confused Betsy, sorry. Confused Betsy is Betsy, but cast to a dog type.
Are they inherited from the same base class? Or?
Yep, so both of them are, well, in C++ and with C, it doesn't really matter if it is the same base class. I mean, you could change a pointer to whatever type you want to, and it'll try to interpret it the best way it can. But both of them are from the pet class. Both of them have the speak function. Here in the code, we see that dog has overloaded its parent pet class, speak, with a wolf, and the cow has overloaded it by returning a moo.
Should it not, if you're casting into a dog, should the name method not resolve to the dog's name method?
That is the question here. So what do you think? Who thinks it's going to say wolf? Okay, who thinks it's going to say moo? There's only two options there, guys. Those that did not vote, what do you think it's going to be? All right, well, let's run it. So right now we're not utilizing the virtual keyword. I'm going to set a breakpoint right here where confused Betsy is. Oops. I did not change my project to be pets. So this is where I was talking about setting the startup project. So now when I hit it, it will do pets instead of the prison project. All right, so right now we just have a couple of things printed out, and that was just from earlier statements where we created a dog, Spike, we created Betsy, we made them both speak. There was an old Yeller class that was called. Now we're at confused Betsy. So this is the point where Betsy should speak. So Betsy said wolf. Good job to those that voted wolf, and for those that abstained from voting. I don't know if that counts as correct or wrong. If we continue, we see that Fido Fido is a new dog, and Fido also says wolf.
So if you cast Betsy to something that wasn't a subclass of the pet class, should the compiler not error out?
I think Visual Studio is smart enough now to tell you, that's going to cause an error. I'm not sure. We can try it right now.
Yeah, actually randomly shouldn't say that.
Class boo. Public. Oops. All right, just testing this out real quick. We'll change that.
Right, are we going to see what happens if you're on send
Yep, I was going to show that before this question came up. We'll get back to that. If I don't, please remind me.
So the pointer to dog just get set to ECX, and then when the main method was called, the result from ECX to dog.
We'll see in just a moment. I like your enthusiasm, though. All right, boo needs a name method and a speak method, so let me get that real quick. So, I mean, you can cast it to anything you want to, but clearly since we are using it in the program, it needs to have certain functions. All right. Survey says it'll still work, just like C. You could just cast it to whatever type you wanted to, and it will try to run with it. Yeah. But I think we're going to have some interesting, well, no, we're not going to have any interesting behavior here because everything, and this can also be shown at this assembly view, but notice we've got confused Betsy, and we're calling directly to boo and speak. The reason for that being is we're using compile time bindings. So at compilation time, the compiler knows what address that is according to what's in the source code. It's not looking at the type of it or making any references or assumptions about that at all. So no matter what we cast it to, it's always going to call that method for whatever it's casted it to. Now, if we were to change this up, we're going to do it again, cast it to a dog, but this time we're going to use the virtual keyword. Now, what do people think is going to happen? Is the cow going to remain sane and say moo, or is it going to be confused and say woof? Can I get a raise of hands? Woof. Well, those are the two options. For those that abstained to vote last time, your two options are woof or moo. So who says it will say moo?
There's a dog.
Who says it'll say wolf? I think there are still people that didn't vote. Okay. Let's test it out. Moment of truth. Confused Betsy says moo. Now, why does that happen? If we look at the disassembly, we see that instead of a call directly to the dog or the cow's function, it has an indirect call to a register. Tracing this back up, ECX is set with a dereference to EDX. Okay, well, where is EDX? EDX is up here set by a dereference to EAX. EAX is set to, what is this? Confused Betsy. So recall, confused Betsy is basically the this pointer. It's what ECX would be used. And as we can see here, ECX is set to confused Betsy before our call. This occurs because we're using the late binding.
How did that look in code again? Like, what did you do differently this time?
The only thing that happened differently in the code was, let me close this out so we can see it better. Before, the first time I tried it, it was this line here, line 39. And line 40 was commented out. Using the virtual keyword caused the function to use late bindings. So the compiler doesn't know what address it should be calling, in which case it needs to set up some more kind of metadata information to calculate that address and call it during runtime.
And why is that done practically? Like, what benefit does it offer the programmer? Like, why would they go with a virtual function on an object rather than just a not such function?
This really becomes dependent on what you want to do. As we saw in that example, us going to this part, and no matter what we cast Betsy to, Betsy will always still remain a cow because she was created as a cow. So, I mean, a developer could use this to ensure that whatever type that they create is going to adhere to those those properties. And that might be due to internal implementation of certain parts of the class. So maybe casting it as another class, which may inherit from the same parent, may cause discrepancies or may cause calculations to go awry, and that's not what they want. They want to ensure that their function for their class is indeed called. So earlier, I drew a little diagram about how the structure was laid out. We had our wardens, we had our prisoners, we had the number of cells. When we start using the virtual call, this creates a new thing called vtables, or virtual tables. So in memory, the class will look like this. You will have a first class, which will entail, where's my mouse? Give me a second. All right. This pointer, or ECX, will be pointing to this point. For Microsoft Visual C compiler, the way that these usually show up, the way they're usually structured, is through this diagram. The first address within inside the object itself is going to be a pointer to the vtable. In the instance where we do not have a vtable, however, there will not be any vtable. It will just be the same as if you were to define a structure. That pointer to a vtable is going to contain all the different methods within inside the class that can be called. And all of those methods are going to be virtual methods. They're not going to be ones that are not defined with the virtual keyword. The reason for the first index into the object being a pointer to the vtable is in order to help understand where exactly these virtual functions are. If it was at any other offset, then there would be a need for more metadata in order to ascertain where exactly the vtable for that function is. So the first offset is going to be the vtable, and inside the vtable, if a destructor was defined with Microsoft Visual C compiler, the destructor is usually the first entry in that table. And that will provide an address for where that function can be found. And then the rest of our object, we have our properties. Again, this is just kind of a generalization of it. This is the way it will happen if you create a Visual Studio project, compile it with just the normal settings. This is usually what you'll see. Different optimizations or different compilers can result in different things, much like GCC will change this up a little bit. So when it comes to actually reversing these objects, what's important to do is to find these structures. If in memory these classes are structured as such, you can create structures in IDA Pro that will allow you to apply them to variables and offsets that you see in order to make it easier. So the class object itself, you will have a pointer to a vtable, and then followed by whatever properties are associated with that object. And then you would need to create another structure that would encapsulate all the functions that it calls. Oops. Now, how can we really understand or know what these structures should look like? It's much like with any part of reverse engineering. It's a puzzle. You have to figure it out. You have to start somewhere. And the best place to start is with the constructors themselves. So where is the constructor going to be found? Well, it's usually going to be found either in the beginning of when an object is first used or created. It's going to be found either at the beginning of the program, good places to look. That's where we're going to find a lot of information about, okay, where's the vtable associated with this class, if there is a vtable at all. And any initialization of properties within inside the class will happen here. In addition, if we do have the scope of inheritance, a parent class and a child class, the parent's constructor will also be called from the child. And this will be a good place to find out what this subclass inherits from. So by default, a constructor, you're not going to see a vtable for a constructor. Was that a question or? Oh, okay. A constructor is usually optimized out because when you create a new instance of a class, the compiler knows exactly where that constructor is. So you will see a direct call to it. You're not going to see any several levels of dereferencing in order to actually call a constructor. Keep in mind, again, when we were talking about we created a class instance on the stack, well, that's going to be a local variable, in which case you're going to see ECX being loaded with a local variable and then a call to the constructor. Whereas if we were to use the new construct in order to create a class instantiation on the heap, then we're going to see something like a malloc, where it's allocating space in order to hold this object right here. So whatever size the vtable plus whatever properties are used by the class, that's what you're going to see a malloc for, which is very helpful because then you know exactly what your structure size is. A lot of times in IDA, Flirt will pick up different signatures. It will be able to show you, okay, well, this is a new call in order to create a new instance of this class. And you'll see a lot of times with this YAPAXI substring. This is just kind of a mangled name that's going to show up. All right, so again, I'm going to loop back around to the fact of visibility. Well, we talked about it, we programmed with it, and some of us encountered some problems where it wasn't public, or it was protected or private, and thus it couldn't be accessed in different places. When it comes to reverse engineering, none of that matters at all. You just completely disregard any visibility scope because you can see and you can access everything. So if you're trying to reverse engineer stuff to go back into its actual source code, unfortunately, you're not going to be able to tell. You can make inferences about, okay, this property in a class is not being accessed directly. It's instead being accessed through a getter function. So maybe I can assume that this was set as private, but there's no way to actually know for sure because those details get lost once compiled. All right, so it's run a little over. I'm just going to finish the slides and I'll walk through an example for those that want to stay around to see how you actually go through about doing it in IDA. When we looked at the disassembly, when I used the virtual function, these were key parts that I was talking about. We saw that ECX was being used in a constructor without it actually being defined or set prior inside the function. So in this example, var8 is a local variable that's being set with ECX. That's the this pointer. IDA is helping us out, telling us that there was an argument passed to it. So this helps us to know, okay, well, the function we are looking at is probably a this call versus a fast call. A hard-code offset, this is going to occur in any constructor for any class instance that has a virtual table or vtable. Because that class needs to know exactly where the vtable is in order to access the members associated with it. This call function, this could be, we'll see, could be either just a call to another initialization function inside the constructor, or it could be a parent class, which the fact that it's loading ECX with this pointer and adding it by 4, that's a pretty good indicator that it's inheriting from a parent class. And that sub underscore 4118b is most likely the constructor for a parent class. So if we were actually looking at a sample, that's a good place to start looking too, because then we can start to figure out, okay, well, what exactly is this, this parent class that is being used? When you start looking at C++ binaries, you start hunting for these vtables because the easiest way to start puzzling out what exactly are you messing with. Is this a big class? Is it a small class? What are the operations that the class performs? If we had a basic number class that we define, we might have an add function, a subtract function, a divide function. In which case, if we found the vtable for all of those, we could tell pretty easily, okay, this is adding 2 numbers, this is dividing 2 numbers, this is subtracting 2 numbers. Whereas if we're just looking at ECX being passed around in the program, that's going to be kind of hard to figure out, okay, this is a number class, something to that effect. So in IDA, what you're going to be looking for is a lot of times a move instruction to a dereference of a register. Remember, in the diagram I had earlier, the V table is going to be the first offset in the object. So ECX is pointing to this address of this object. It is going to be dereferenced and assigned a value, a hard-coded value, and that's a really great indicator that it is a V table. Once you go to the actual address of the V table, you will see address after address that corresponds to actual code inside the binary. And if you find yourself doing dynamic analysis and you think what you're dealing with is an object, start looking at the ECX register. Once you dereference that, you can see, okay, is this taking me to a V table? If it is, then most likely it is a object created being used. So once you're able to find one V table, it's going to be a little bit easier to find many more, or at least also find other constructors associated with that class object. You'll be able to find constructors, and from constructors, you work your way back to see where those constructors are called. And then you can start tracing through, okay, well, ECX, this is an object, this is its constructor. Where is ECX now being used? And from finding the constructor, the V tables, you can then understand what virtual functions correspond to it, create those structures in IDA in order to better define what functions are in the V tables and the class itself. So here's a little bit for additional information. All you guys have the two samples. Apologies for going over there a little bit. I'm going to stick around, so if anyone's really interested in me walking through some of the actual IDA reversing of a C++ binary, then stick around. If not, you guys are free to go to lunch, and thanks for attending.